Hey everyone, in this video I'm going to teach you antiderivatives and show you how to solve problems with them. If you already understand what they are and just want to see the examples, please look for the timestamp in the comments or description down below. So let's get into it. If you have a function f of x where the derivative of that function is f prime of x, the antiderivative of the derivative of f prime of x, the antiderivative of that, is equal to f of x plus c. This makes sense because the anti means you go the opposite way, so it gets rid of the derivative. Okay, so we also add the plus c because the derivative of a constant is 0. And we don't know what that constant is, so we have to add that. So we signify we are taking an antiderivative through this symbol here, which is called the integral sign. And the function in between the dx and the integral sign is called the integrand. So in this case, it's f prime of x. And also make sure you write dx on the end, so you know what variable you are integrating with respect to. You should also know that the integral, or the antiderivative, you can use this interchangeably, by the way. The antiderivative of f of x dx is equal to capital F of x plus c. And you can verify this by taking the derivative of capital F of x plus c, and we'll get that it's just equal to f of x. So another formula you should know is called the power rule for integrals, which lets you take the antiderivative of a function of the form x to the power of n. Okay, so this is just equal to x to the n plus 1 over n plus 1, over n plus 1 plus c. And you can verify this because if we take the derivative of this, we should get we should be left with x to the n, because that's the integrand. This is f of x, and this is capital F of x plus c. So if we use the logic up here, if we take the derivative of capital F of x plus c, we should get f of x. So let's find out what this is. So if we use the power rule for derivatives on this, we could bring the exponent out in front and then subtract 1 from the exponent. And it's all over n plus 1. And then we can see that these are going to cancel. And then the 1's are going to cancel. And we're just left with x to the power of n. And the c goes away because it's a constant. And because this equals that, we just verified that that formula works. Okay. So you should do this with all antiderivative formulas you get to verify they work. Just so you know, and it's easier to remember them. So some more formulas to know are the integral of 0 dx, or the antiderivative of 0, is just c, because the derivative of a constant is 0, so we get that. We get our integrand. Also, the antiderivative of a constant k with respect to x is just equal to kx plus c, because if we take the derivative of this, like if it were 4x plus 3, we would get just k, the constant. You should also know that the integral of k, a constant, times a function, f of x, is equal to k times the integral of f of x. This makes sense because if you take the derivative of k times f of x, the derivative is just k times f prime of x, so that also applies to integrals. Because it would be like, the integral of this would be k capital F of x plus c. So it's like derivatives. Okay. So finally, the integral of f of x plus or minus g of x with respect to x, that's just equal to the integral of f of x plus or minus the integral of g of x with respect to x. So this basically just means if you have a function like x squared plus x, you can take the integral of each term separately, like you would taking the derivative. So that's all you have to do for that. For trig antiderivatives, I have another video covering them separately next week, but the same logic still applies. So for example, the antiderivative of cosine of x with respect to x is just equal to sine of x plus c, because the derivative of sine of x plus c is just cosine of x, because you get the integrand if you take the derivative. Okay. So now that I've taught you what antiderivatives are, let's just get right into the examples. Okay, so for our first example, let's find the antiderivative of 8 minus x dx. So the first thing we should do here is realize we can split the integrals. So it'd be like that, and we can just subtract the x. So you can basically just distribute the integral sign and then pull the negative out, because it's really -1. So now we can just take the integral of each separately. So the integral of 8, using the formula I gave you earlier, is just 8x plus c. And then this is going to be minus the integral of x, which is just using the power rule, x squared over 2, because you add 1 to the exponent and divide by that exponent, plus c. Now we have to realize here is that these c's, they don't necessarily have to be the same value. So you might think that they would cancel because the negative distributes to here, but they actually don't. So you can just write this as 8x minus x squared over 2 plus c. That's the answer. So just always write the plus c no matter what. So for our next example, let's find the derivative of the antiderivative of x to the power of 10 with respect to x. So using the power rule, we can just add 1 to the exponent, and we're going to get x to the power of 11. Divide by that exponent, it'll be x to the 11 over 11. and then add plus c. So this will be our answer. Now let's find the integral of x to the 7 plus 4x plus 2 dx. So again, we can just distribute the integral to each term, but we don't need to rewrite that again. That's too much work, so we can just take the antiderivative of each term separately. So we're going to have x to the 8 over 8, because you add 1 to the exponent and divide by that new exponent, plus 4x squared, add 1 to the exponent, and then divide by that new exponent. And then for constants, you just add a x to the end, and then you add your constant c. And we can simplify this a bit by canceling the 4 and the 2. So we're going to be left with x to the 8 over 8 plus 2x squared plus 2x plus c. And that's going to be our answer. Okay, now let's find the antiderivative of dx. What is this? Well, this is really just the antiderivative of 1 dx, because we don't actually have to write the 1. It's always implied. So the antiderivative of that is just going to be x plus c, because if you have a constant, any constant k, it's just kx plus c. That's the formula from earlier. But if you had 0, of course, it would just be equal to c. Sorry, dx. So, yeah. Okay, so now let's try finding the antiderivative of 2 dx. Using the formula earlier, this is just 2x plus c. Now let's try the antiderivative of 8 with respect to a. So what would this be? Well, if we're taking the antiderivative with respect to a, we just follow the same logic as above. The formula still applies, but we just change the x to an a. So it's 8a plus c. All right, now let's try the antiderivative of x over 4 dx. Well, this is really just the antiderivative of a fourth x dx. And we can pull constants out, like a fourth. We can pull them out of the integral. So it'll be a fourth times the integral of x with respect to x. And now integrating the x, we're going to have a fourth times x squared over 2 plus c. And now we can just distribute the fourth in, so it's going to be x squared over 8 plus c over 4. Now, by convention, mathematicians, they don't leave this as c over 4, they just leave it as plus c. So the 1/4 wouldn't apply to that. So it's just going to be x squared over 8 plus c as our answer. Okay, let's do another example. Let's find the integral of 1 over x to the power of 9 with respect to x. So this is really just rewriting it. It's just the the integral of x to the negative 9 with respect to x. So now we can just use the power rule for derivatives, or for integrals, sorry. So if we add 1 to the exponent, so negative 9 plus 1 is going to be negative 8. And then you just divide by that new exponent. So divided by negative 8. Then we just add plus c. And we can rewrite this by bringing the 8 down to make it positive, or the x to the 8 to make it positive. X to the 8. So it'll be 1 over negative 8 x to the 8 plus c. But it's always good to write the negative up top. So it's going to be negative 1 over 8x to the power of 8 plus c as our answer. Okay, so now let's try finding the antiderivative of the square root of x with respect to x. So like the last problem, this just requires you to write the exponent in a bit more of a simpler form for us to work with. So it's going to be x to the 1/2, because that's what the square root means. So it's the antiderivative of x to the 1/2 with respect to x. So now we can just use the power rule. So it'll be it'll be x to the 1/2 plus 1 over 1/2 plus 1 plus c. So 1/2 plus 1 is just getting common denominators. It's just that, or 3 over 2. So it's going to be x to the power of 3 over 2 over 3 over 2. And now we can just bring the 3 over 2 up. So this is really just x to the 3 over 2 over 1, but divided by 3 over 2. So now we can just multiply by the reciprocal of the denominator. So we can just rewrite this as 2x to the 3 over 2 over 3 plus c. And now we can write this back in radical form, because that's how they presented the problem to us. So it'll be 2 square root of x cubed over 3 plus c, because the 3 up here, that becomes the exponent of x, and the 2 becomes the index for the root we take. So it's the square root, which implies a 2 here because it's there. And then it's just x cubed, and this is going to be our final answer. And for our last example, let's find the antiderivative of x plus 6 divided by the square root of x. With respect to x. So let's just follow the same logic we did in the last one. So it'll just be x plus 6 over x to the 1/2 with respect to x. Now here we don't really have any rule to deal with integrals of this form. We can't immediately use the power rule. So we're going to have to simplify this a bit more. I think if we split the fraction into x over x to the 1/2 plus 6 over x to the 1/2, we could then use the power rule for integrals to find the antiderivative. Okay, so we can rewrite this again as x times x to the negative a half plus 6 times x to the negative a half dx. So this is really x to the 1. So we can just multiply this in. So we just add exponents when we're multiplying them. So it's x to the 2 over 2, which is equal to 1. So it's 2 over 2 plus a negative a half is just going to be x to the 1 half plus 6x to the negative a half dx. Now we can just integrate each term separately. So we saw that the integral of x to the half from above here is just 2 square root of x cubed over 3. So it'll be 2 square root x cubed over 3. And now we have to take the antiderivative of this. So let's write that out real quick. So all I did here is just pull the 6 out, because if you remember the formula from earlier, since 6 is a constant k, you can just pull it outside the integral. And now we can just take the antiderivative of this. So let's focus on only this for now, ignoring this. Okay, so if we use the power rule on this, it's going to be x to the power of negative a half plus 1 over negative a half plus 1. So this is really just getting common denominators. It's going to be negative a half plus 2 over 2, which is equal to a half. So it's going to be x to the half over a half. And now we can multiply by the reciprocal, because this is just x to the half over 1 over 1 over a half. And those cancel. By 2 over 1. And then x to the half is just square root. So this is just equal to 2 times the square root of x. So let's erase this real quick, since we know this is equal to 2 times the square root of x. Okay. So it's going to be 2 square root of x cubed over 3 plus 6 times 2 times the square root of x. And then don't forget plus c. So it's 2 times the square root of x cubed over 3 plus 12 rad x plus c. So it's always going to be plus c, by the way. We don't need to do anything special with that. And this is going to be our answer. I think we should do one more example just so we really understand this. So let's try the integral of x to the 4th minus 3x squared plus 5 all over x to the 4th. So like the previous example, when it's division like this, there's nothing immediately obvious that we can do, like using the power rule. We can't directly apply a formula, so we're gonna have to simplify this a bit more. So I think if we did the same thing we did in the last problem, by just splitting the fraction, we might be able to use the power rule. So splitting the fraction, it's going to be x to the 4 over x to the 4 minus 3x squared over x to the 4 plus 5 over x to the 4. So these cancel, and then these cancel. So we can simplify this to write it as 1 minus 3 over x squared plus 5 over x to the 4th dx. So the integral of 1 is just going to be x minus the integral of 3 over x squared plus the integral of 5 over x squared, or 5 over x to the 4th dx. Sorry, I forgot that. Yeah, it's very easy to forget writing dx, so make sure to always remind yourself to write that. Okay, so now we can just take the integral of these separately, so because they're not immediately obvious what it is from the power rule or from any of our formulas, so we're going to have to simplify things a bit. So this is really just, let's tackle this one separately. So this is just the integral of 3x to the negative 2 by rewriting it, and then we can pull the 3 out. So it's 3 times the integral of x to the negative 2 dx for both. And now we can just add 1 to the exponent. So it's going to be 3 times x to the negative 1 divided by that exponent. And then we can neglect the plus c for now because we can always just add that on at the end. So we're good there. And then moving this down so we get a positive exponent, it's going to be negative 3 by moving the negative up top, multiplying the 3 in, negative 3 over x. Okay. Alright, so let's write that in. So it's x minus negative 3 over x, or x plus 3 over x. So x plus 3 over x plus the integral of 5 over x to the 4 dx. So now let's find the antiderivative of this. So this is really just the integral of 5 times x to the negative 4 with respect to x. And to make this more simple, we can pull the 5 out. So it would be 5 times the integral of x to the negative 4 with respect to x. Now we can just use the power rule, add 1 to the exponent, and divide by that same exponent. So negative 4 plus 1 is negative 3. So it's x to the negative 3 divided by negative 3. And then again, we can neglect the plus c until later. So moving the x to the negative 3 down to the denominator, so we get rid of the negative exponent, and moving the negative up top and multiplying the 5 in, we're going to have negative 5 over 3x cubed. So let's write that in. Negative 5 over 3x cubed. So this will just be x plus 3 over x plus negative 5 over 3x cubed plus c, or x plus 3 over x minus 5 over 3x cubed plus a constant c. And this will be our final answer. Okay, so if you like this video, make sure to subscribe to my YouTube channel. Let me know in the comments down below if this video helped you or did not help you understand antiderivatives. Thanks for watching.